Hello everyone, this is Indradeep Kumar, Assistant Professor, IARE, Hyderabad. In last class we had seen some numerical. So again we will see in this video next numerical which is related to the Goodman relation. So now in this we will see numerical on Goodman relation. So what we had seen in the theoretical part, now we will use same in Goodman, that numerically. So here is your question. A material has a fatigue limit of plus minus 230 Newton per mm square. So just see a plus minus 230 means it's given as a range. And an ultimate tensile strength of 870 Newton per mm square. So what is given here? Ultimate tensile strength is given. If the safe range of stress is determined by the Goodman prediction, calculate its value. So now what here it's mentioned that by Goodman prediction, what is find? A safe range of stress. So we have to find by the using Goodman relation. So now let's see this. Already as we know that what was the Goodman according to this theory, that was same as A, that amplitude, by SA naught. In this case this will be there SA naught, whatever the like straight line equation. That okay, first see this one, x by A plus y by B is equals to 1. This is the equation of a straight line having x intercept A and y intercept B. In same way we will use for this straight line, that is for m equals to 1. If it's not m equals to 1, that is m less than 1 and greater than 1, then this will be changed. So later we will see next question according to that. So okay, just see first. So with this what we will do, x by A plus y by B equals to 1. The same way we will use here. So just see here, if suppose this is your x-axis and this is y-axis, so along this what we are taking, this one, this is Sm by Su. So this intercept from here to here is your Su along Sm. So by this if you will write, then Sm by Su plus, so this is for x-axis, right? Now for y, so Sa and at this one, at this point, so Sa, that is variable, by intercept is Sa naught, right? This should be equals to 1. So this is along x-axis, x-intercept, y-axis, y-intercept, that must be equals to 1. Now take this, because what we have to find, we require to find Sa, right? So we will keep Sa this side and we will take Sm by Su to that side. So now Sa by Sa naught should be equals to what? 1 minus Sm by Su, right? So from here what we can write? We can write that Sa equals to Sa naught into 1 minus Sm by Su. Okay, now this is given. So now see the question what is given here. Okay, the limit is given, fatigue limit of plus minus 230 and ultimate tensile stress of 870 Newton per mm square. If the safe range of stress is determined by the Goodman prediction, so according to that, once we will find, then what we will get? Here let's see. Now Sa naught, what will be Sa naught here? So Sa naught is given in the form of range. Range means what? Up to minus 230 to plus 230. Once you will add, you will get what? 2 into 230, right? After multiplying, or once you will add, then it will be 2 into 230 as what? And 1 minus Sm. Sm, now we are writing what we can write Sm as Sa by 2. So we are writing Sa as Sm as Su by 2, because we know the Sa. Sorry, we have to find Sa. Sa by 2 into Su. Okay, now you know the Su value. So let's put here. So Sa is equals to, now just see, I'm putting here. So 2 into 230 into 1 minus, now Sa will be Sa by this 2 into 870. Okay, So after this, we will see what? Just simplify here. So SA is equals to, this will be what? 460 into 1 minus SA by, this is 2 into 870, or you can just multiply by using calculator and you can put. Now just see, first multiply this one. So I'm just expanding this one. So SA equals to this one, first this to this, and then we will multiply this to this, then it will be easier. So 460 into 1 minus 460 into SA by 2 into 870. Once you will find, take this to this side, SA one side. So now after simplifying, what you will get? This is same, 230. So SA plus SA by 2 in, sorry, already we did 870, and here is 230. This should be equals to 460. Right. Now take SA common and then divide the whole thing. You will get the final answer as SA equals to, sorry, SA equals to approximate to 333 Newton per mm square. So let's see what is required here. Simply what we have, SU is given in the question, this value. SM we know as SA by 2 in terms of the factor of safety, right? SA, just from here in this figure, you can see SA by S0, that is y-axis by y-intercept is equals to 1 minus x-axis by x-intercept, right? Then just replace this SM in terms of SA or SU if it's given, whatever. If you can, then so means only one variable should be there, then only you can find y, because this is the linear equation. For linear equation, only one unknown should be there. So we changed SM in terms of what? SA. Now just only you have to simplify, and after calculating you will get the value of SA is this one, right? So this is for should work when it's the linear relation is there, that is this equation of linear. When if it's not linear, meaning what? Either for this one, that is m greater than 1 or m less than 1. So that time what we can write, that same n equals to 1 and n equals to 2 or n equals to 0.5, like that we can write. So related to this, we will see the next numerical. Okay, if that is not a straight line, that is if it's not following the m equals to 1, then how we will solve that one. Okay, so we will see that in next numerical. So let's see. Now, a more accurate estimate for the safe range of stress for the material of that question is, the previous question is given by the non-linear form. Actually, this is previous question. From previous question is given by the non-linear form of the Goodman prediction, in which m equals to 2. Calculate its value. So now here that is given what? Goodman prediction, that power as 2. Remaining everything you have to use according to the previous formula. Okay, now see the answer. So what was there again in this time? This m will be there, not m equals to 1, because it's clearly given m equals to 2 in the question. So for the linear one, what happened? Which is varying, according to that we have to see. So first let's see the general formula and then we will put the value later, right? So now this will be same for y-axis as SA by SA, 0 plus SM by SU power m. Now this will vary, right? This is equals to what? 1. Take this side. So SA by SA naught equals to 1 minus SM by SU, right, power m. So now we have this formula. Earlier what we have? This again in previous we can use this m, but there it's a linear, so m equals to 1 we have taken. So now in this case m is either greater equals to 1 or less than equals to 1. So whatever the value we will have, we will put, and then we can find SA. Now in the same way you have to do, just the difference will be what? Here again just what? 2 into 230, this one is clear. Just change SA by 2 SM, that SM equals to SA by 2, that earlier we had seen, and this 870 already is given. Here only the difference will be, this will be the power. Now this power makes difference, then you cannot calculate directly, right? Then how will, so first after expanding this, we will get a what, quadratic equation, because power is there, so we will solve for those quadratic equation. Okay, so now let's solve this one. So first what we have to do, we have to expand this one. So I'm writing this as SA equals to, just multiplying these two, so 460, okay, 1 minus SA square by 2 into 870 square, right? Just as wrote separately. Now what we have to do, either you just first take LCM and then multiply with this one, or just multiply this, simplify, and then again taking LCM. So let's do SA equals to what, SA by 4, SA equals to 460 minus 460 into S square, SA square by 2 into 870 square this time, right? So now from here SA will be equals to what, 460, right? Now this 2 square, so I'm writing this as 4, so 4 and just 1, so this will be 115, so 115 SA square by 870 square, right? 460 minus, okay. Now you can just take LCM, and once you will simplify this one, then after solving, this will be the equation. Or just see, let's see. So after just taking LCM, SA into 870 square, so later you have to divide by this. So after simplifying this equation, right, you will get as this equation, SA equals to, or just by simplifying this. So after this, what we will do, okay, because now just see here, SA square is there, so power 2 means it's a quadratic equation. So for this we will solve. So what we have, I'm taking this to this side also, or take this whole thing to this side. This will be better, positive. Okay, let's take. So now what we have, this will go that side, so it's positive 1.519 into 10 to the power minus 4 SA square. This is already positive, so plus SA, okay, minus 460, this equals to 0, right? Now this is the coefficient of SA, this is here, so coefficient of this is 1 and this is constant. So now we can use formula like what, AX square plus BX plus C equals to 0 in the quadratic form. So now here A is, that constant is this one, 1.519 into 10 to the power minus 4, okay, and variable is here SA, right? So just see SA square, now this SA, so here B is 1 and C is minus 460. So you can go by the formula or by just middle term splitting 1, anyone, or just you can use your calci, okay, to find SA. So this will be the final equation, right? After solving, you will get two equations. One will be negative and another one will be positive. So once you will find the approximate value of SA, you will get like 432 Newton per mm square. So this will be the answer by Goodman relation. So now just see here what we used this graph, right? By this graph only we solved, and that's why during that class also, earlier video also I said this graph is very important, and with this only we will get the data to solve the numerical. And just see, from there only we found this one, right? So in question, that like same here, they will change M, right? Sometime they will give you SU in terms of endurance limit, like in later we will see. So that ultimate stress in terms of endurance limit they will give. So whatever is there, just how one is related to other, that only you have to see. And just after interpreting the formula, right, you can solve the equation. The basic equation is this only, right? For a straight line, you can put m equals to 1. And if this is not given directly, then you have to first see how you can find Sm, or how you can change Sm in terms of any given data. Once you will have that one, just substitute in this equation and you can get directly answer. Okay, so let's recall once again, right? In this case, what we have to find, safe range of stress, right? We just move through what, m equals to 1. For that, we found simply SA naught by 2. So after cross multiply this, just we got this one, and Sm we change as what, SA by 2. So SA by 2 is this Sm. Su is given in the question itself. Just substituted. After this simplifying, you can further simplify, or you can directly use calculator to solve. I already solved this one, so again I'm not solving. So finally you will get as 363 Newton per mm square. If instead of this straight line, if curve is there, any like for m greater than 1 and m greater than 1 and less than 1, that is any other value than 1, then here in this question, right? So in this again, same thing we have taken, just the power of this will get changed. In previous question, that will be m equals to 1. Here, that is whatever the value is given, that you have to take. So according to the question, here m is 2. So just put 2. Remaining everything will be same from the previous equation. Previous question, because it's mentioned you have to take from the previous question. And after that, just substitute, expand this one, you will get the quadratic equation. Once quadratic equation you have, you can solve by any method, either by middle term splitting, by formula, or by using calci. Then you will get two values. So one will be positive, another one will be negative. So you will get SA as approximate to this one. Clear? So now in next class we will see another numerical, that in next video we will see numerical related to the same first module, and after that that is still 3-4 videos are left for the numerical. That means minimum 2 videos we will have for the numerical, and then we will go for the second unit.
Like, share and subscribe. Hit the bell icon for more updates.